Hi class, in this lecture what we want to do is we want to talk about applications of equations of the form ax is equal to b. So think about this lecture as kind of like a bunch of real world applications for solving linear equations. So two objectives here. We want to talk about applications of percent. There's going to be a bunch of examples there. We're even going to do like some interest examples, and then we're going to move into talking about uniform motion examples. All right, so let's talk about the applications of a percent. So solving a problem that involves a percent requires solving the base percent equation. So the base percent equation is the following. P times B is equal to A. So it's percent times the base amount is equal to the amount. So to translate a problem involving a percent into an equation, remember that the word of translates into multiply, quote unquote, and the word is translates into equals here. So the base usually follows the word of. So, it might be something like find 20% of 50. Okay, well, that would mean 50 would be the base. So of translates to multiply, and is translates into equals here. All right, so here's an example. During a recent year, nearly 1.2 million dogs or litters were registered with the American Kennel Club. The most popular breed was the Labrador Retriever. Okay, with 172,841 registered. What percent of registrations were Labrador Retrievers? Okay, round here to the nearest tenth of a percent. Okay, so first off, what are they asking us to find? They're asking us to find percent. Okay, so looking back at our equation, they're asking us to find the percent here. All right, so we're going to use the base here is the total amount, the 1.2 million, changing that to 1,200,000 here. And the amount of the Labrador Retrievers, the A, is 172,841. So the percent, as I said, is the unknown here. So percent times base is equal to A. Well, percent times the 1.2 million is equal to the number of Labradors. To get rid of this 1.2 million, just divide both sides by 1.2 million. If you take this and plug it into your calculator, you get 0.144. Just changing this to a percent, I move the decimal places two ways to the right. So it looks like approximately 14.4% of the registrations were for Labrador Retrievers. All right, let's talk about simple interest. So the simple interest that an investment earns is given by the following equation. Interest is equal to principal times rate times time. So I is equal to P times R times T. I is the simple interest amount. Principal is how much you initially invest. R is the rate that you're getting on the interest, and T is the time. Okay, usually it's going to be in years, but it can be months, things like that. All right, so in April, Marshall was charged $8.72 in interest on an unpaid credit card balance of $545. Find the annual interest rate for his credit card. Okay, so the interest I here is $8.72. The unpaid balance is $545. Okay, this is the principal on which interest is calculated. So there it's telling my principal. Great. The time is 1 month. Okay, because we're talking an annual interest rate. Okay, must be found, and the time is given as 1 month. We're going to write time as 1 divided by 12. Okay, because we're only looking at 1/12 of the year. Therefore, my T variable is 1/12. So to find the interest rate, okay, so we're looking for R. We're going to solve this equation for R. So we'll just replace the values, okay? Interest is equal to principal times rate times times. Forgive the little typo here. This should be 12 instead of 2. Excuse me. So the interest is equal to the principal, which was $545, times the rate times the time, which is 1/12. So we have $8.72 in interest. Just moving this 12th over here to 545 divided by 12 times R. Multiply both sides by the reciprocal. Obviously, this cancels. If you take 12, multiply it by this, then divide by 545, you get 0.192. So the annual interest rate here was 19.2%, which is high, but that's generally what it is for credit cards. All right, let's talk about mixture problems. So problems involving mixtures are solved using the percent mixture equation. Excuse me. Q is equal to A times R, where Q is the quantity of the substance in the solution, A is the amount of the solution, and R is the percent concentration of the substance. So quantity of the substance in the solution, A is the amount of the solution, and R is the percent concentration of the solution. All right, so to make a certain color of blue, 4 ounces of cyan must be combined with 1 gallon of paint. Okay, what is the percent concentration of cyan in the paint? Okay, so the amount of cyan is given in ounces, all right, and the amount of paint is given in gallons. All right, that's fine. We must convert ounces to gallons or gallons to ounces, doesn't matter. For this problem, we'll convert gallons to ounces, so you can look up that 1 gallon is equal to 128 ounces. Therefore, my amount here, my A, amount of the solution, is 128. The quantity of cyan in the paint is 4 ounces, so that's my Q is equal to 4. So to find the percent concentration, okay, we're just going to solve for R. So the 4 ounces of cyan is equal to the 128 ounces of the gallon times the rate. So just divide both sides by 128. You get 0.03125. So the percent concentration of cyan, just changing this to a percent, is 3.125%. All right, let's talk about uniform motion now. So any object that travels at a constant speed in a straight line is said to be in uniform motion. So constant speed, straight line. Uniform motion means that the speed and direction of an object do not change. For instance, a car traveling at a constant speed of 45 miles per hour on a straight road is in uniform motion. So the solution of a uniform motion problem is based on the equation D is equal to R times T. So its distance is equal to rate times time, okay? Suppose a car travels at 50 miles per hour for 3 hours, okay? Because the rate 50 miles per hour and the time 3 hours are known, we can find the distance traveled very easily by the equation distance is equal to rate times time for D. All right, so distance is equal to rate times time, 50 miles per hour for 3 hours. The distance here is 150 miles. Pretty straightforward. All right, let's try this one. 2 cars start at the same point, move in opposite directions. The car moving west is traveling 45 miles per hour, and the car moving east is traveling at 60 miles per hour. How many hours will the cars be at, and how many hours will the cars be 210 miles apart? Okay, a little tricky. The distance, 210, okay, that's what we're looking for. Therefore, our distance in this equation, D is equal to R times T, is 210. The cars are moving in opposite directions, so the rate at which the distance between them is changing is the sum of the rates. This will be true whenever they're moving in opposite directions. So the rate is actually 105 miles per hour. Therefore, R is 105. So to find the time, all right, just solve for T in this equation. So distance is equal to R times T. We want them to be 210 miles apart. We know that their rate here is 105 miles an hour because we're moving in opposite directions. We add their rates. So divide both sides by 105. You get T is equal to 2. So in 2 hours here, the cars will be 210 miles apart.